Good day. So today we are going to discuss about projectile motion. First, we must define what is projectile motion. Projectile motion, it refers to the motion of an object that is launched into the air and moves under the influence of gravity alone. It follows a curve called parabola. So the image of this parabola or this projectile motion is something like this. If we have an object that is being thrown by something like cannon, let's say a ball, and it is being launched at this point, and we have a certain angle that this cannon is being pointed to, the result of this object that is being pushed by a certain force will have a trajectory that look like this. The object will follow this trajectory and will form this trajectory. It is all because of the gravity. As our object is being pushed by its acceleration or its velocity, there is that a component for y and component for x, wherein in each certain time this component of y and component of x, the velocity at y, the velocity of x will change. This will be x new, y new. So as you can see, at a certain point we also have this is the highest point, wherein our object will have the velocity equals to 0 at y-axis. We also consider that we neglect the air resistance. It means our object won't experience any resistance due to the air. Secondly, the acceleration due to gravity is constant and acts vertically downward. So this is our acceleration due to gravity. That will cause our object to fall down after it reaches the highest point. So, as for the formula, we will just use the same as formula as what we have learned in rectilinear motion. Firstly, we have velocity initial plus acceleration times time. At a horizontal motion and the vertical motion. We know that the acceleration along x is equals to 0 and the acceleration along y is equals to 9.81, or acceleration due to gravity. Firstly, we have the acceleration, we have the velocity at the horizontal motion. So as shown, a is equals to 0. It always is 0 because there is no resistance. That is why the acceleration won't change. There is no an air resistance that could possibly change the acceleration. So here we're going to put this velocity of x, or velocity initial at x component, this component here will added to acceleration, which is equals to 0, and time. Means this will be added by 0. So the horizontal motion will just be equals Vx equals to V initial at x component. At vertical motion, we have Vy is equals to V not y minus. It is a negative sign because the gravity is acting downward and our object is acting opposite to the gravity. That is why this here is the sign that our gravity or the movement of our object is against the gravity. It will be g times gravity times time. Next formula, we have distance as v naught time plus 1/2 at squared. Here we're going to substitute again and assume this s as x, since we are looking for the x component. So s will be x and v naught will be v naught x times time, and we have acceleration here which is equals to 0. It means that this whole equation here will be equals to 0. So technically our x is just equals to v naught x component times time. At vertical motion, we have y. We used y because we are going to find the y component. So y is equals to the v naught of y times time. Since our object is acting against the gravity, we can say that this is negative times the 1/2 of gravity times time squared. And lastly, we have number 3, which is v squared is equals to v naught squared plus 2as. And we assume that s is equals to x if it's in the x component and y if it is in the y component. Since we are going to find horizontal motion, we have v y squared is equals to v naught x squared plus, since we have a here, it is equals to 0, this whole equation here will be equals to 0. That means that our Vy is just equals to V naught x squared. Since we have both sides squared, we can actually square both sides and cancel the squared. So our final equation or the final formula for the horizontal motion is Vy equals to V naught, not Vy, Vx equals to V naught of x. And here we have Vy squared is equals to Voy squared plus, no, not plus, it is minus, since our object is still against gravity, minus 2 gravity, and our s will become y. So these are the k formulas that we have in our projectile motion. Next, we are going to have another formula using this equation here so that we can find the distance y or the component y easily. Let us say y is equals to v not y times time minus 1/2 gravity times squared. We know also this v naught here, our v naught x here is equivalent to the v naught of cosine theta. This is already given since we are going to find to which direction our velocity along x component goes to, and our v naught y is also equals to v sine theta. Using this formula, we're going to substitute this to here. We can find that y is equals to the v naught sine of theta. Now, we're going to find that t we're going to find the value of t using the horizontal motion, using this formula here. So we know that if we divide both sides by v naught x, the result will be equals to time is equals to x over v naught x. And we have here that the v naught of x is actually equals to the v naught cosine of theta, meaning this time here is equals to v x over v naught cos theta. Next, we are going to find here minus 1/2 times the gravity. Again, the time is equals to the x v naught cosine theta. Right. Now, we can see that these two here, this v naught and this v naught, will cancel each other, or v naught divided by v naught will become 1. And sine theta over cos theta is the identity for tangent theta. Sine theta cos theta x minus 1/2 g, and this will become squared, it's x squared over v naught squared cos squared theta. And this sine cosine here is equals to tangent theta times x. No, rephrase. Y is equals to the x, and the identity for sine theta over cos theta is tangent theta minus 1/2, it's x squared, it's gx squared, gravity times x squared over 2 times v naught squared cos squared theta. And this will be our formula that we are going to use to find the y component, or also we can find the x by arranging the formulas. So now let us proceed to the next discussion, or let's proceed to an example. So let me just erase this one. Okay. So, situation. A projectile is fired from the edge of a 150-meter cliff with an initial velocity of 180 ms at an angle of 30 degrees with the horizontal so neglect air resistance. First, we are going to draw what the problem has given us. So projectile is fired from the edge of 150-meter cliff. So let's assume this is our cliff. That is 150 meter. Right? Now we have the projectile, or we have the object here that is being fired at an angle of 30 degree with the horizontal. So we are going to neglect the air resistance. Now this projectile here this object here will have this path taken, right? So first question, it is asking for the, let's say, first question, let's say A, find the horizontal distance from the gun to the point where the projectile strikes the ground. So it is, wait, let me write the question. Find the horizontal distance from the gun to the point where the projectile, or the projectile strikes the ground. So firstly, we can use the find formula last this derived formula, we have the x tangent of theta subtracted by the g x squared theta 2v naught squared cos squared theta. We know our y, which is this 150 meter. But notice that the 150 meter is below the datum to where our object started, wherein after this, if it passes this horizontal from our gun or from the launching point, our object will have its trajectory at a negative side, right? And this will be the positive side. So meaning this y over here will take the value of negative 50 m, which is standing or stating that our projectile has crossed, or this height is below our launching point. So first, we take y, which is negative 150, and our x, which is this x here, which is what is our looking for, right? So we have x tangent of 30, tangent of 30 minus the 1/2 of minus 9.81 x squared over 2. Our velocity is 180 squared cosine squared at 30 angle. So if we calculate this, 150 alpha equals x tangent of 30 minus 9.81 x squared over 2 times 180 squared cosine 30 squared, then we should get the value of x is since this is a quadratic equation, so we have two roots, which is negative 239.72, and we have the x sub 2, which is 3099.98 meter. So there is no such thing a distance with a meter value, except this if it is below the datum. So we should take the positive value. So our answer is this 3099.98. Next, we have the question for letter B. This, we should determine the total time of flight. See? So it is asking now the total time of flight. So let's remember that we have a formula for the time of flight, which is this total time here, is this time, is what we are looking for. So we can have this formula using by the vertical motion, which is y is equals to dv naught of y time minus the 1/2 of gt squared. So this formula is useful. We are going to use to find the value of time. Since our y is negative 150, and it is equals to the v naught of y, which we know that this v naught y is equals to vo sine theta, right? So it is actually is 180 sine of 30 times the time subtracted by a half of gravity, which is 9.81, multiplied by time squared. And using calculator and algebra, we are going to find the time here. 30 time minus 81 over 2 alpha x squared. Here we can see that it is still a time is still in a quadratic equation, so we should assume that there is a negative input or negative time. This time, since I already input a positive value of x, so I already find that value of our time is 19.89 seconds. So this is the time flight taken by our object or our projectile. Next, we have the third questions. It says C. Determine the greatest elevation above the ground reached by the projectile. Elevation above the ground reached by projectile. So, to find the highest point located or the highest point taken by our projectile, we will note the velocity. Our velocity at the highest point, we know that this velocity at the highest point should be is equals to 0. Since it is asking the highest point, so we assume that it is the highest point wherein the velocity will going to equals to 0, since it will going down after it reaches the highest point, right? So we are asking this point here. So Vy is equals to 0 ms, and our y will be equals to h, and our v naught, of course, it is 180 ms. No. Vy is 0 ms, and our theta will be 30 degrees. Now we will use the vertical analysis formula. We have Vy squared is equals to V naught y squared minus 2gy. We know that our Vy is 0, and our V naught is equals to the V naught sine, which is our V naught is 180, and the sine 30 degree squared subtracted by 2 multiplied by gravity 9.81, and the y, which is equals to h. And h here, using calculator, h will be equals to 180 sine 30 squared minus 2 times 9.81 alpha x. So our h is 412.84 meter. But this height is this height only. We only calculated this h here. This y is not included. So we should add here at 412.84, should add the final height, the highest height. So let's put it as big H. The highest height should be equals to 412.84 be added to 150, so that this height here, this height, we can find this height. So it is 150. It's 500.84 to 562.84 meters. So that will be our example for this projectile motion.